check, 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 check. All right. Is everybody ready for this? Are you guys ready to rock? I always wanted to do that. You guys are like, never do that again.
We appreciate your feedback.
All right. Let's get this ear thing on my ear a little bit better. See if we can get this rocking. All right, there we go. War walking at Defcon and BlackHat. Welcome, everyone. Have you had a great con? That's what I'm talking about. This has been epic this year. So I'm a little bit sleep deprived. I'm a little bit crazy. Definitely brought this guy up here to help me out because I need some support and help, and plus, he's the man. So we'll get into who we are here in about 2 seconds. About us. My name is Mike Spicer. I go by the handle Dark Matter. I'm a hacker of hardware and software. I've got a degree in computer science, and that's about me.
Henry Hill, IT, hardware, everything he just said except for the degree. The pictures of us, you can pick who's who.
All right, warning and disclaimer.
So, drinking, eating, breathing, hearing this presentation may increase cancer risk or cause birth defects. Don't be evil. Be careful with some of the stuff that we're going to show you today. It's got a lot of different applications, which we'll also go through. We brought this for the presentation. We actually ended up using it to crack some of the hacker challenges here. And, you know, do try these things at home under a controlled circumstance, but be careful how you're doing that. Don't target your neighbors. Do it on your own stuff. Use common sense. Not a hard thing to do.
And we're not really going to talk about how we're hacking into things, but we're going to kind of talk about how we're watching things. But in the process, you'll see some things going on here. So let's talk about some objectives. So I'm going to give you some brief 802.11 primer. And for any experts in the room, just plug your ears because this is going to be embarrassing. And I apologize right now because I just want to give you enough so that you can understand what I'm talking about in our analysis. So yeah, just get your ears on for the next few slides about the primer. And I'm going to make it quick because this isn't about primer. This is about war walking, the data, and that. So the other things we're going to talk about is the hardware we use to gather. We've got the hardware here on the table. Afterwards, you can come up, take a look at it. We can talk about it. We're also going to talk about how we gathered some airwaves, our analyzation techniques, how we got to higher levels. And then we're going to talk a little bit about WPA cracking. I was going to do a live demo of trying to crack some WPA, but we're having some problems interconnecting because I've got that disk encrypted. I don't have a head on it. So I apologize. We won't do a live demo on that, but I've got some screenshots, I think. Yeah, I think I've got some screenshots I can show you. Then we want to talk about future changes because whenever you do a project like this, you always have things you want to change. We could talk about some lessons learned, and then we'll wrap it up. All right, so to begin with, 802.11 is magic. And wireless in general is magic. It just works. It's amazing that it actually even connects at all. So in the 802.11, you have frames. It's kind of like in Ethernet, you've got layer 2 intercommunication between switches. In this case, they're frames, and there's multiple types of frame. You've got a management frame that handles your authentication, the association. Beacons, they're the items that you can see when you pull up your list of networks that you can connect to. There's deauthentication, there's disassociation, there's probes, reassociation, there's a ton of them. Just if you're interested in going deeper on 802.11, you could spend and become an expert on it, like Wi-Fi Luke. And then you've got control frames. So these are the things that are helping to control when devices are already connected. So you've got like ACK, RTS, ready to send, clear to send. And then you've got data frames, and this is where your payload is. This is where things that we care about that are higher levels, TCP, all that fun stuff, that's in your data frames. See, I promised it'd be quick and dirty, so all right, we're pretty much done with it. I got a cool little header graph. So one thing real quick, I want to talk about the header reference on the frame because this is going to be important. We're going to look at some Wireshark, is the addresses. There's 3 types of addresses. You've got, sometimes it could be your distribution system address, there's the source address, and then the destination address. So there's 3 different types of addresses, and we'll see that as we move forward with this, but just keep in mind that those addresses are MAC addresses typically. All right. So getting the airwaves, our custom hardware, I've got a picture of it up there, and I've got it here. basically what we've got is BeagleBone Black, and I'm running Debian on it. And then I've got two alphas. I've got an alpha black, which is the AWU SO36NHA, which is the Atheros chipset. And so that card is really good at going into monitor mode, it's capture mode, and then you can also turn it into an access point. So it's my most favorite. Plus, I think, I might be wrong, but I think it's about 23 dB on its gain, so it's a really powerful card. Then I have another Atheros card that's the PCB you see in there, and it's if you look on websites, you'll see it's an Atheros green. It's an 802.11n card. It's green, but it's not. It's a Realtek chipset, and it doesn't support monitor mode. Well, I guess with the latest, it does support monitor mode, but you can't go into managed mode. So I need it on there because I wanted to use Wi-Fi as my uplink, and I'll show you why in just a moment here. But I wanted to have this in my backpack, control it from another device, and then be able to walk around conference or whatever without anybody knowing that I'm war walking, basically. All right, so then I've got a powered USB hub. So I learned a lot about powered USB hubs in this situation when we were doing this because some of them aren't rated for very much amps. And when you start putting multiple wireless cards in a setup that are pulling 200 milliamps, you start having problems with power. When you start having problems with power, that means you're starting to wreck the rest of your setup. And then in addition to that, there's certain types of hubs that don't work very well with ARM processors, it turns out. And thanks to the Raspberry Pi forums, I found a bunch of people who had already pre-tested. And this Belkin one that I have now, in the picture I had an Amazon one that worked, but it was kind of finicky. I have this Belkin one that's been rock solid ever since. So it's powered. I'm plugged directly into a battery source, so I can draw up to 2 amps out of that through this high power powered USB hub, which powers the BeagleBone Black, which is about 100 milliamps, and then I've got my 2 alphas. So it's kind of a crazy setup, but it allowed us to have just be able to walk around a conference for about 9 hours straight without having to swap a battery or anything. And in this picture, I was using a battery pack that was just a simple USB, brick that you can get. And since then, I found Adafruit has a really cool lithium-ion charger where I can hot swap batteries without, as long as I have the USB cable in, without losing charge to the rest of my system. So it gave me now additional uptime. I just have to go take a break and take a knee and swap batteries. So. All right, this picture right here, I want to kind of, as we go through this, we're going to kind of show some pictures. This picture was us on the way to the conference, had it on the dash the whole drive, so we started things out right by getting our capture on from, we're from southern Utah, so it's not very long to get down to Vegas, so got a capture on the drive. All right, so hold on, wait. Why not use something off the shelf like a Wi-Fi Pineapple? Well, before I went to Defcon, I thought that, I found out actually that the 2 radios in the Pineapple, how many of you guys are familiar with Wi-Fi Pineapples? A couple of you? So they have 2 radios in it, which you guys know, but I wanted to do wireless to wireless communication. So I wanted to use one as the access point and that's communicating to my laptop, for example, and then the other one that's connecting from that's the monitor that then is listening. But I found that that intercommunication between there was throttled and limited to about 2 megabits. So when you started monitoring and trying to dump traffic, and I'm trying to do live Wireshark, it was just choking, was dying, because I mean, 802.11n, you can get up to 150 megabits through that setup. Plus, the Realtek chip on there is only 802.11g, because they put it in there for frame modification and not necessarily for that type of a setup. So I was like, well, that's why I didn't use a Pineapple. I'm going to build my own rig because this is going to be awesome and we're going to go rock this thing. And so that's why I didn't use it. But then, funny story real quick, I went to the Wireless Hacking Village at Defcon to hear a talk by Darren Kitchen and Sebastian, who are the creators of the Wi-Fi Pineapple. And I asked them a question during the Q&A about that limitation, if they were planning to fix it, because it turns out it's an SPI limitation on the communication. And they said, well, why don't you just take the Pineapple and plug your alpha into the USB port? And I was like, you can do that? I was completely blown away because that thought hadn't even entered my mind. So if you want to use a Pineapple, The form factor is awesome. This is kind of obnoxious. I got a lot of custom stuff, and I've definitely short-circuited things playing with this. The Pineapple is the best way to go, and then you can plug your alpha in, and then you can do this type of a setup. The only thing you can't do with that is, I guess, plug multiples in, but you could get a powered hub. A little bit learning curve there, so definitely check out the Wi-Fi Pineapple because they are amazing. All right.
So this is the actual layout of Defcon itself. This is the convention center. This is a map of it. You see Paris, Bailey's on there. And this is the main areas we were walking. So we did this for all 5 days of the conference. We were moving around, going to the main areas. There's basically no spot within the convention that we didn't hit.
In addition to this, we went to BlackHat for 1 day, but I couldn't find a map of it, so we don't have a map. Sorry.
This is outside the convention center, or just at the entrance of it, inside of Paris. You guys are probably familiar with that sign. This is to show everybody knows about waiting in this line, trying to get into Defcon and how crazy that was, but there was a lot of devices here that were looking for Wi-Fi APs. Now, you can see that there's a lot of public people in here as well, because this was the strip mall shopping center, so nobody was immune.
Well, real quick, too, because they had previously had DEF CON at the Rio, which is kind of off the strip and out of the way, so it was pretty much just geeks and hackers at DEF CON, but then this year they put us with real people, and so things got kind of interesting.
We're not real people. Wall of Sheep, you guys know this one as well. This is just kind of showing you the basic areas we hit. We tried to stay in the really populated areas just to see what kind of vulnerabilities existed and who actually had their Wi-Fi and Bluetooth accessible. I'll let Mike take this one.
Okay, so thanks to a good friend of mine, he let me, well, first of all, the Cyber Defense Grand Challenge guys brought I think it was 1/5 or 1/6 of their supercomputer to DEF CON. And they had security guards, and like nobody got close to it. It was basically between me and the front row away. That's as close as you got. Well, thanks to a friend of mine who let me up close, I was able to take my war walking rig and go start walking around it. And I asked it, can I plug into it? Can I just plug into a switch? Like, no, you're not doing anything. But I got close enough to see if there was any wireless coming off of it, and as far as I can tell, there was not. But that would have been rad. So, all right, so I'm going to talk a little bit now about gathering the airwaves. So how do you do that? I didn't want to go crazy in depth on giving you guys a tutorial or a workshop on how to do Aircrack NG, but Aircrack NG is what I'm going to talk about. I want to give you the base commands and just kind of talk about some of the caveats that I ran into. So starting a monitoring device, Airmon start. There was a really good talk on Monday also, if anybody saw it, that he went into the workshop and broke down how to break into wireless devices, which I caught a good chunk of it, which was pretty good. So anyways, the Airmon NG, you just start the wireless into monitor mode. Once you get into monitor mode, you run air dump. I love air dump. It's quick and easy. I love using tools that are quick and easy. One thing, though, to note here is that when you don't specify the channel, it just kind of hops. It just is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then flips and just keeps hopping those channels. So the problem with that is when you only have one radio and you've got all these channels and you're constantly switching, you're only getting a subset of that data. You're only getting a chunk of that frame, those wireless frames that are out there. So we'll talk about that more in a bit, but keep that in mind about that channel hopping. You know, you might miss something cool that's happening. And then the last thing I note here is being able to use T-Shark. Any of you guys use T-Shark? Familiar with T-Shark? So if you've installed Wireshark, it typically will install T-Shark also. It's a command line tool that allows you to do all the filters and things that you're doing in Wireshark, but on the fly from the command line. So it's kind of like TCP dump, but TCP dump doesn't really work with wireless frames. So T-Shark will get you that other supported protocols that Wireshark has. I also use T-Shark for my analysis because then you can, once you have a PCAP file, you can read in that PCAP file with T-Shark and then do your analysis from there. So pretty much all the analysis I did was using T-Shark. All right, so sometimes you want to capture things in the background. When we first were driving down to Vegas and we had this set up, I was having to pull out my laptop and type a bunch of crap, and then like 10 minutes later, I'd be like, okay, Henry, I think I'm ready to go war walking. And then I'd be like, No, 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 not ready yet, not ready yet. And then obviously we were taking forever, and it was just a pain in the butt. So what do you do when things need to be replaced in life? You replace them with a very small shell script. So that's what I did here. So I just used screen to demonize the service, put it in the background. I'm running, I named it Warwalk, sorry. So that way I have an association to pull it back up. And then I'm running the command aerodump ng monitor, and then I'm writing it to a file. And that file, in this script, it's just a single file. I actually modified it since I created this slide, where it will actually keep track of the day and then add a number, so that way you don't ever. Oh wait, it doesn't. It automatically will not overwrite. So yeah, that was what I did. So it just kept track of the day of the week. All right. So this is what it looks like when you get it running good. You should have output where you've got SSIDs. This is aerodump. Aerodump's pretty cool screen that you can see what's going on. It's quick and easy. This is just a list of APs. It also has client information. Don't want to go too deep into that right now. All right, so real quick, I want to talk about some analyzation techniques. So there's a couple different ways to do it. You can do frame analysis in Wireshark. Wireshark's awesome. Like, it supports so much stuff. And the problem, though, is it's pretty grueling. Like, when you start getting into it, it's pretty much by hand. But at the end of the day, it's super flexible, and if you don't know exactly what you're looking for, it can be really helpful. So the problem, though, is it's horribly time-consuming. Another thing you can do is you can get your capture file filtering with, oh, I left off the T there, T-Shark or T-Shark or Scaly. That's autocorrect right there. It's supposed to be T-Shark and Scapy. So I promise Scaly is not a new thing. Autocorrect failed. Okay, so Scapy, if anyone's used it, it's a Python, Python plugin, framework, whatever. It's a Python thing that you can import into Python. It's import into Python, and then you can search. The problem I found with it is it wasn't very fast or efficient. These things are excellent when your criteria is repetitive and you're trying to do the same type of analysis over and over again. For us, we're like, what do we want to know about our data set? We're like, I don't know, we have data? How do we do analysis? This is weird. We've never been analysis guys too much. There's usually always tools that we're using. So the problem with using something like that's auto-scripted with T-Shark or with Scapy is that sometimes it can fail on you, and if you have a very custom requirement. And since we only captured data for a few days and we're not doing recurring, it just made sense that at the end of the day, just do our analysis in Wireshark. All right.
So I don't always make up statistics, but when I do, they're 100% accurate. This is kind of the data that we were able to pull while we were down there on the devices themselves. Some of the information we wanted to know, like if you had to guess, what type of devices you thought you'd see, you'd probably say, Apple, Android, etc. So there was a few surprises there. We have a little bit of a map here that shows that Apple was #1. The Zebra was actually their point of sales units, their Wi-Fi APs, their wireless within the hotel itself, which we did not factor into the equation. So that scored a strong second that we were capturing. Then after that, you can see it's mostly Android devices down to Intel and Microsoft after that with individual manufacturers.
And so this is unique MAC addresses that we saw here. So this was pretty surprising to see just that level of Apple devices. Now, the other thing with Zebra he mentioned is I was blown away with the number of access points the hotel had. Like, they have probably 2,000 to 3,000 that I saw in just our Warwalk, which is crazy. Then that's between the Paris and Bally's. So, and they use the same because they're basically the same company as far as I could tell. But again, and I had never even heard of Zebra before. So really just interesting information that we found. Okay, so another cool thing we found is, devices are vulnerable. I don't know, can you see that all right, or is that really crappy?
That's really crappy.
Oh man, I made that really small. Okay, so anyways, what it's trying to show is that there's a lot of devices that are asking, they're like, hey, are you my home wireless network? Are you my home wireless network? Are you my home wireless network? So, and it turns out that
We
this
were their home
guy
wireless.
might be the most vulnerable guy that I saw at the con.
This is really annoying when you're trying to work and this guy's next to you in the room and you need wireless. So you basically have no option. So I just threw myself in the pool with everybody else just to, confirm the testing and see what kind of data we were actually getting back. So he's got both my phone and laptop on there as well. So
and it wasn't just like it was his phone or laptop. It was like his phone and laptop were both saying, "I'll connect to Starbucks. I'll connect to McDonald's. I'll connect to hotel such and such."
Exactly.
It was amazing. So it just goes to show you that like we're kind of security minded a little bit, and yet there's still vulnerabilities among us. So especially at the con, and we did see vulnerable devices to Karma. So theoretically, like if you talk to some device guys, especially Apple nowadays, they're like, no, you can't Karma attack us. Well, I guess, are you guys all familiar with the Karma attack? Do I need to explain how it works? I'll give you a quick rundown on it. So basically what it is an access point basically says, I hear beacons, the people trying to connect, because your device is leaking networks that it has connected to in the past in order to try to see if they're available. So then it was made pretty much huge by the Wi-Fi Pineapple. This is one of its first big attacks. It's like, oh, I hear all these devices. We'll all set up all these access points for you to connect to. So let's say you're sitting here at SaintCon, and all of a sudden it's like, my home custom wireless network that's really cool pops up, and you're like, hey, I'm connected to it. Like, how did that happen? I'm not at home. So that's the Karma attack in a nutshell. So... All right, so something else we saw, I know this one sucks, but you can kind of see some of the corrupted SSIDs. We saw some attacks happening, and in this picture, man, I apologize about the picture. The slides are available, so you should be able to get that information, check that out. But in this picture, you can see that, well, you can't see, but what's in there is that the pineapple, there's some Wi-Fi pineapples in here that are broadcasting, so that's kind of interesting. Why would people have that if they're not probably staging an attack? But then right around that pineapple broadcast is some corrupted SSIDs. So there is some vulnerabilities, like people test input box fields all the time and like just throw just anything they can into it and they fuzz the crap out of it. So obviously people are going to try to throw anything they can into a wireless SSID and then see if that breaks somebody's equipment. I'll tell you what, I've had some industrial control systems that when they connect wirelessly to something that isn't like ASCII, like just the base characters of ASCII, uppercase, lowercase, and numbers, it freaks them out. So you can find neat things. It's one of those out-of-the-box type things. And then this page, you don't necessarily have to see the actual data, but just that they're all the same. And there's one key word here. It says deauthentication. So how many of you are familiar with deauth attacks? A couple of you, all of you pretty much? Okay. So the idea here is, I clearly saw somebody doing a deauth. If you see one or two deauths in your Wireshark, it's probably like, it's not a big deal. You know, maybe it's management of the network or there's a controller or something happened. But when you stretch this out, and I think this I caught of the frames that I caught is like 120. When you see 120 on the screen, clearly something weird's going on there. Somebody's attacking something. All right.
So that's the total number of unique SSIDs that we saw. This was what we were able to capture, 6,891 individual SSIDs that were trying to connect to their home wireless, their work wireless, whatever it may be, and we were looking to record that information.
So I'm going to jump over to Wireshark real quick. And, whoa, I forgot that we got resized here, so let's try to make
life easier.
Oh, man. Well, that sucks. The basically inside of the info frame over here on the right-hand side, it has the SSIDs. It doesn't stretch. Maybe we can hide a column real quick.
I'm down.
Yeah, we're hiding all the columns. Oh crap! Don't do that.
Oh, demo fail. So anyways, what you would have seen over there if we scrolled over was actually my home wireless on there trying to connect to it. So it was FBI surveillance van or something like that on the right side. And that was my laptop, I believe. Actually, within the room trying to connect to the home wireless, it was one of those things that was difficult to avoid, and I was okay doing it while we were in the room because I knew the unit was recorded. And we wanted to see what the range was, kind of get some test results off of units that we knew were working, that we knew were looking to connect to those random networks. And this was the information we were able to pull from it. You can scroll through and just see all these individual home networks, their SSIDs.
Before I scroll too far, this was caught in Vegas at Defcon, these SSIDs, so I take no responsibility for what may scroll on the screen real quick here. But there might be some favorites that we might see here. Everyone can see it okay, right? Of course, I want to make sure that you can see it. So that was your warning. If you don't want to see things on the screen, just look down. But anyways, so here's one that's kind of funny. Source Frenchie. Yeah, it's pretty funny, some of the things people put on there. There's the FBI surveillance van. There you are, Henry. I found you. That's his laptop beaconing out saying, I want to connect back to home. So there's a vulnerable device.
Yes.
Also, real quick, I want to just make a reference. Inside of Wireshark, the commands are all under the wlan.fc, and there's also wlan_management mg. MG. It looks like we're doing good on time, so I'll do a couple other filters. There's some really cool cheat sheets. There's probably about 40 different commands to go through and troubleshoot different parts of wireless. And I definitely recommend you guys look those up because it's neat. You can find out really neat things about your network. This helps for analysis. You can look at different broadcast things from a PCAP file. You don't have to have a spectrum analyzer. You don't have to have a capture, professional capture thing. You can just do it with PCAP and then throw it in Wireshark. Like, that's the best thing ever. All right, so let's just see if there's any other funny ones here real quick while we scroll down. You can see like this, we were capturing this, we were in range of Bally's, so we're definitely at Bally's, and we're also in Paris, and they're really close together, so it kind of bleeds over. Let's see, you spotting any funny ones, Henry?
Not seeing anything.
So this one, it has special characters, like I was talking about before, where you have, wait, what are you laughing at?
Look at the one you're on.
Yeah, where's up here on this William Cleghorn one? That one isn't necessarily like they purposely put in special characters there to try to do something. What that probably is because we were channel hopping, we only caught like a subset of the frames, and that was loud.
Yeah.
We only caught a subset of the frames, and so some of that SSID got corrupt in that process. So that's one of the things that can show up in doing the channel hopping, is because that SSID is only being broadcast on that channel all the time, or that device is only going to request that on the certain channel. So in this case, that's probably why that corruption happened. But in some cases, when you look at it and like there's a ton of special stuff and like some hex, or like maybe somebody's trying to do an SQL injection in an SSID, because that would be awesome if that worked. You might see that. So just things to think about. We'll just scroll down, see if there's anything more cool going on here. I hacked your face. That's pretty awesome. I'm not gonna. This is like 300 or 400 megs of this is my subset, and my laptop is a piece of crap. So I can make some of these PCAPs available if you guys are really, really interested, and we'll filter and search and then post them online and put them on Twitter. I will make them available to you. So hit me up afterwards and PCAPs, or it didn't happen. All right. A little bit more of this fun madness of SSIDs. See if anything else comes up. Oh wait, I saw some. Anything else?
Totally not a trap. Drop table. There's drop table, SSID. There you go.
So somebody already did it.
Clever. Mr. Really Happy.
All right, one more, and we'll get back to it.
You can do this all day.
Yeah.
We need to get through this.
I started writing a ton of like scripts to just go through and like do unique, and then I was piping it to sort, and then I was piping it to awk, and I was doing all these things to try to cut all this out. And I was gonna have this really cool list, and we were gonna go through, and we were gonna pick our top 10.
Yeah.
And then the vault challenge happened. And that thing was amazing. And so we
this
lost
is what you get.
We lost like probably like 2 days of this conference to the vault challenge because of how awesome we thought it was. So yeah, so now you get scrolling lists with lots of broadcasts and unfiltered. I apologize.
Doesn't look like anything good.
All
We
right.
can move on.
Moving on.
No.
Okay, so now the really, really, really scary part. We caught some handshakes. Sorry, we didn't mean to. We were just listening. So how many of you guys are familiar with the WPA handshake process? Anybody? Raise of hands. Oh, man. I'm just not very good at explaining it. Basically, it's a 4-way handshake. So, like, TCP is a 3-way handshake. This has an extra step. So think of SYN, ACK, SYN, the same thing, but happening at layer 2 to be able to do it, but it takes 4 pieces for the client and the access point to intercommunicate. So it's 4 separate pieces that you have to capture in order to try to crack that. And we caught it, and we were jumping spectrum. So every time we jumped that spectrum, or jumped channels rather, then we're gonna miss it. Because usually the only time you can capture these is when a device goes to connect to that encrypted network. So it had to be disconnected and then it's reconnecting, or it's connecting for the first time. So there's attacks that you can get more of this and find more handshakes, you know, the DAuth attack. But we didn't do it. We weren't doing anything offensive. I wanted this to be solely passive. We were simply listening. And we caught this number of handshakes, which is, in my opinion, was just crazy that we got this number of full handshakes. So what do you do when you get handshakes? We'll get to that in a second, actually. Sorry. All right, real quick, one thing that I wanted to talk about is going to higher layers. Because, you know, doing all this wireless stuff and beacons and SSIDs, that's all cool and stuff, but, you know, what's the use of it if you can't get to TCP data, you can't get to UDP data? So Wireshark actually has built-in decoding, and it's amazing. So it will automatically go through and try to find any of the data frames and anything that's unencrypted, the WPA2 that's just unencrypted. It will try to decode those frames and then immediately turn those into TCP and UDP packets that you can then just use Wireshark to search for those. So now one of the nice things that they have in Wireshark 2 is, let's say you do come across a WPA, WEP, or WPA2 key, you can actually plug that into Wireshark, and then it will go ahead and decode those layer 2 encrypted frames for you, and now you can jump to those higher layers. So let's say you're doing a pen test or you're testing your home network and you want to see what's going on your wireless network. Set up your monitoring rig. You already know your WPA2 key, right? Because you're going to do it on your own stuff. You type that into Wireshark, and then guess what? It turns it into like wireless happy land. It's like a hub. Unless you have very specific access points that do client isolation, wireless is like a hub. If you can hear the radio waves, you're able to see those devices intercommunicating. So when I first did this, I was like, oh my gosh, they brought back hubs. I'm so happy. Finally, I can get back to some more data that I've been missing. Stupid switches. Anyways, like I said, there are access points that have tricks to do some client isolation where they do some enhanced filtering at the physical layer so that way you would never even see it at the layer 2 level. And but you know, who has those? Probably this university, I'd imagine, and some other big people that have lots of money. But for the most part, you know, on your home wireless system, I bet none of you do it. So go home, set up some monitoring, and just any laptops, stuff that's connecting wirelessly, it'll blow your mind if you haven't already done that before. All right.
So this is the actual cracking side of it. So for those handshakes themselves, this is the hardware side. This is what we threw at it. To go a little deeper into this is about, we used to have, I don't know, about 40 times this available to us. This is kind of our mobile version. It only takes one power supply that usually doesn't pop very often, and 3 R9 290X cards. They're 4 gig a piece cards, about 2,500 processors a piece. And they're a lot faster. They're a lot faster than anything that you're going to have in your laptop, things that are just completely unreasonable in regards to trying to crack it on a nice laptop or even a desktop is made easy with this. The other specs of it are we just run minimal RAM, i3 processor, small solid state drive. None of that really affects performance on the overall rig itself. And then the software side itself is
Kali 1.6, and then we're using OCL hashcat to crack. So we were going to try to do a quick live demo of showing you how we actually do a crack, but for some reason I can't get it logged into. I made it work too hard by cracking some SHA-512 salted hashes for the Vault Challenge, and now it's tired and it's ready for a break.
So we had some people attempt to run those challenges alongside this. So for kind of an evaluation on speed on this unit, a nicer, newer laptop, say an i7 with a decent graphics card, will take about probably 50 plus days to do what this will do within 5 or 6 hours. So we were usually solving within the first 3 or 4 though. Estimated time, say for the challenge that was here out of the vault on this machine, was 13 hours total. We popped it in about 3. Somebody tried to do the same one on their laptop and they were at what, 56?
56 days is what I heard them say.
And it wasn't a terrible laptop. It wasn't some old Pentium M unit. So it was a new i7, top of the line, nice card in it, just nowhere near the power of this. And like I said, this machine is halved. We normally have double the cards, double the power supplies, and that's just for one unit. It's just kind of unwieldy to pull that around.
So when we do run this at 100% on these graphics cards, it gets their temperature up to about 80, 85 degrees Celsius, and there's just nothing you're going to do about that. And that's core temp, so that's on the inside. We've tried, like when we were running our Litecoin business, we were trying to keep things cooled, and we found stuff just runs stable at 80 degrees C. So we're like, whatever, we're just going to let it happen. So the upstairs in his office was literally like an oven in the middle of winter.
The inner cards usually pop at about 95. So we found they could handle about 90 to 92 C, okay. Fans would warp and fail. It's just part of the game. Just stuff melts. It happens. It's a small micro furnace, so it's more than just a hashing rig.
Don't worry, AMD was awesome about RMA.
So they never asked any questions, so we never provided any answers. Yeah.
So one other thing I want to note about going back, because we're talking about just regular hashing there, the SHA-512 salted hash that we had for the challenge, which is a shadow file of a modern Linux or Unix operating system, is much similar to the WPA handshake. That handshake is salted with the SSID, so you can't rainbow tables it. You can't do pre-computed hashes on it. So that's kind of problematic. And so because of that, it's really slow to crack WPA2 handshakes. So unless you're targeted by the NSA and you've got somebody with unlimited resources coming after you, you might be all right with a really long key. So, all right, there's a demo fail. Demo fail.
We're just going
to tap out on demo now today, but all right. So let's talk about some future changes. So one of the biggest future changes, because I've talked about a few times already today, is that we missed frames because of the spectrum hopping of the channels, or the channel hopping rather. We missed a lot of data. We may have lost a lot of interesting things. So why not run more radios? You can just plug in more radios, listen on all of those different channels. I definitely want to do at least a minimum of 3 or 4 more radios. But then that's going to present a new challenge. Each of those is going to be drawing about 200 milliamps of power. Now my entire power setup is going to change, and we're probably just going to have to strap a car battery to his back as we walk around the conference next time you see us. All right, so some other things I want to do is capture in other bands. So this setup is distinctly, or is specifically for 2.4 gigahertz only. You can get some radios that will do 5 gigahertz also. We didn't have that in this setup. Honestly, this setup was what, like a week before Defcon.
Yeah, this was a
We
pretty
got
quick
together
build.
and are like, hey, you want to like capture stuff at Defcon? Wouldn't that be
Everything.
awesome? We didn't know what we were gonna catch. We didn't know. Everybody's always like, that's the most scary wireless network, and at BlackHat, those are the most scariest networks ever. Turn off your wait. What was it? Hide your Wi-Fi.
Yeah, hide your Wi-Fi, hide your children. So.
And so we wanted to just kind of confirm that and just know for ourselves. We didn't really anticipate what we'd find, and that it was actually really cool, and there's really scary things going on. The other thing too that I want to do is I want to jump on and capture a ton more data or a ton more other wireless, like using a HackRF. How many of you are familiar with HackRF? Or a RTSD, it's hard to find radio, STDR. With those, you can just grab any part of the spectrum that you have an antenna for, basically, and then you decode it all in software. And so I think it'd be neat to integrate that into this as well, because at DEF CON they did have a wireless scavenger hunt, and there were people just running around the conference like frantic with random weird antennas. I saw one person that had like an antenna that was like as big as they were, and they're just like, oh, I heard it. Did you hear that? Did you hear that? It was cool, and I'm like, we could totally compete in that next year had we had a HackRF, and we're able to get that. The other thing I want to do is, back real quick on the capture other airwaves. So there's some research that's being done right now on people capturing CDMA, well, they've been doing that forever, but LTE. And so I don't know all the legalities of it. I'm not a lawyer, but that sounds interesting to me. There's this really cool project called the Blade RF that has support for decoding LTE frames in hardware. That doesn't mean that they're cracking them. That just means that it can process them fast enough. You can't process them fast enough with the HackRF. I talked to the creator of this, Michael Osman, and he's like, yeah, you won't be able to do LTE. It's just too complicated. But something like the Blade RF, it costs about like $300 or $400 more than that one does. And so, but that's interesting. So that might be something that we might be talking about in the future, because that sounds interesting. Because a lot of people at DEF CON were like, I'm turning off my Wi-Fi, turn off my Bluetooth. My cellular, I'm fine. I'm going to log into work. I'm doing my work emails because cellular is totally awesome. But is it really? We don't know, because the FCC is like, you guys can't even like blink at that, or else you're going to go to jail. So I don't know. I'm going to look into the laws, contact DFF. So maybe that might be a future presentation. All right. Another thing that we want to do is we want to distribute nodes throughout the conference.
This was a big thing. Knowing position was a really big thing, because while we got a lot of cool analytics out of this data, one of the things we would have really liked to know was where were these attacks, deployed at? Where was the main choke point? What were they really targeting? And you can kind of do the reverse of that too. If we were listening to that information, we could actually go and find the people that were doing the attacks and maybe have some interesting conversations.
Or even just, hey, where were we when we caught that packet? Like, that was cool. Let's go back there. Because we didn't know, because it was hard to correlate
Hidden
time.
SSIDs, networks, things like that.
Let's see. Some other things, some software changes I'd want to do is live tweet the war walking progress. I set up a Twitter account. It was like called DEFCON War Walker. And I tweeted like 2 times, but then it was just so much work because it wasn't automated. I want to fully automate it, so that way it's like, start Warwalker, and then it tweets out, and then that way like people that can follow, maybe I could have like live stream of some of the PCAPs and stuff. I don't know, I've just got some fun ideas like that. And then the biggest one is we did quite a bit of analysis just to get the samplings of data that you saw today, and I want that to be all automated because I'm not a data analyst guy. I think that's dumb. I'm sorry if you do that. That's awesome. You're amazing for doing it, but I can't do it. So I'm not very good at it. I want a one-click button that's like, here, have all the data analyzed for you. So looking into options for that. One other thing is strategy, just more wireless, because we only caught just the smallest footprint of the conference. Us walking back up to our room, out to the conference, and we only spent 1 day at BlackHat, and it was like, not really a real day at BlackHat, because we went and saw a few, like 2 talks, and then went to the vendor area, and then I don't even remember where else we went.
That was it.
And so it wasn't a real day there, and so definitely want to go there and get a better sampling so we can do a comparison of BlackHat versus Defcon. So if anyone wants to sponsor us to go to BlackHat next year to do that analysis, yeah, hey, let us know.
You'll get first look at the information.
Yeah, we'll share. All right, so real quick, just want to go over some lessons learned before we're out of time here. Vulnerable devices are real and they're rampant. They're everywhere. So even though your phone providers like Apple's like, nah, it's fixed. It's not. We saw Apple devices that are bleeding out. People still change the settings to say, yes, I want to connect to networks. People are still setting it up. So I guess to counter that, what you should do is be cognizant of what's in your preferred network list and what you're connecting to, and then turn off your Wi-Fi when you don't need it. When you don't need to be sharing your SSIDs and things like that, just turn it off when you don't need your Wi-Fi. Bluetooth, same with that. Wi-Fi attacks really do happen at these places. Like, people are doing it. There's probably Wi-Fi attacks could have gone on here. I don't know. I wasn't listening on the airwaves here. I was doing the Vault Challenge. But they really happen. So it's something that happens. It's scary. So if you're an administrator of a wireless network and you're not capturing frames or monitoring your network at this level, and you don't have controllers that are doing this for you, definitely invest in some. I think this whole box right here is less than $100. Invest in something that's less than $100. You can set this up and you can start doing wireless monitoring in your network around your business, and you can start getting access to that data. The other lesson we learned is we just need to increase the channels that we capture to reduce fragmentation. So we ended up with capture data that was about 7 gigs of total data from I think it was 5 or 6 days that we were there total. But of that, only 230 actually made it through T-Shark as valid capture data. So that just goes to show there's a ton of stuff that we only had really fragmented parts. So essentially, we had started capturing a frame, then we were like, oh, we're going to change the channel, and then it's like, oh, that we lost anything useful there. So definitely more radios in the future. And position. Position, I think, is a huge factor, because knowing where we picked up things, or even just where we were when we were doing things, I think it would be interesting to be pointing at a thing and to be like, see that map right there? We were right there. We saw this attack happen. And then you can draw proximity of where that source of that attack happened. So working on some ideas. That's really hard because you can't just integrate GPS. So for some reason, it doesn't work in hotels and convention centers. I don't know why. Something about roofs. And finally, the last thing is WPA2, as long as you're using a pretty decent long pre-share key, it's pretty secure. The demo I was going to show you was of one of the handshakes we captured. I threw RockU at it, and then I also did a couple of up to 12 characters of, or 12 length of 0 to 9 numbers. And like between that, I spent like 6 days trying to crack it, and I didn't get anywhere. And it's like, okay, I'm exhausted. I don't even want to try it. And it's going to be too expensive because this runs about 1,200 to 1,500 watts. So that's going to be quite a bit of bucks that's going to show up on my power bill, and I really didn't care. I just wanted to proof of concept to see if it was something simple. So basically, that's the moral of the story. Anybody have any questions for us? We got about 7 minutes. It looks like. Yeah. Okay. So he's asking if we've looked into do FPGA for cracking. So when we were doing Litecoin mining, we started switching to ASICs, and I started learning VHDL to start doing some FPGAs to do that. So that would be rad, but the price and programming to be I think there's quite a barrier to entry there. So I would love to if I had free time. I've wanted to do VHDL for quite a while, but just it's one of those things I haven't got to. But yeah, that would be awesome. Rumor has it at Bluffdale they have like huge banks of FPGAs that they use. I don't know. I've never been there. If anyone wants to take me on a tour, though, if you know anybody, I'd be glad to go on that tour. So
the other thing is the FPGAs too kind of lose their resale value. You can use this for other things, and they're kind of always in demand. And these are always higher end graphics cards. So the FPGA is just different application and. Just too cheap to spend money on them, basically. So.
Yeah. We're about $2,000 on that machine right now, but it's a little bit older. We've got R290Xs, which those are selling for what, like 350
Yeah, when we
now.
bought these, it was kind of at the height of everything. So these cards are probably at 600, where they're less than half of
You
that
could probably
now.
build that for about $1,000 right now, maybe 1,100. Any other
Did you talk to
questions?
them after the mount?
Oh, hey, we got just a few minutes. If nobody's else got questions, anyone dying for a question? Okay, so how did this happen? Oh, well, it didn't work. So
Special
I can unplug
wiring.
it. Okay, so one of the things, the bonus features I want to talk about is this little guy. So the DC801 guys 2 years ago had a badge. Well, I'm a DC801 guy too, I guess, adopted. Anyways, we had a badge for a party that we wore on wrists. I don't know if you guys seen it on Twitter or whatnot, but it was my inspiration for this. So I had this PCB made, and then had I put the screen on it. I'm running a Teensy behind it, and then I've got a wireless dongle that will intercommunicate. That's the ultimate reason why I wanted to have the back channel wireless. So then I could start war walking from my wrist. So if you want to come up as soon as we're close out officially, you can come see this and then that. I wanted to be able to control it, say start my attack, stop, my war walk, and go directly from my wrist. So that was a little piece of hardware we put together as a little bonus. So you can come check that out if you're interested. So, all right, any other questions? All right, we're going to call it. Thanks, guys.
Thanks.